Welcome to the new LPEpower show, where we will discuss basic concepts regarding car technology, and today we will take a look at the gearbox that I made for a German customer. The gearbox was basically made to accompany Barmans V8 engine, as you can see here. You can find the instructions for Barmans engine in the description down below. And now let's take a look at how the gearbox works. First, I'm gonna fire up the engine. There, the engine works. Very nice. Okay, so what do we have here? It's a manual gearbox with 4 speeds and a reverse. Here is the clutch. The clutch works basically like in a real car, with flywheel, the clutch cage, with springs, and the friction plate, which is in this case Lego tire. Here is the clutch actuator. There, you can see it. Okay, and here we have the forks. The forks are responsible to change the synchro clutches, basically the normal Lego synchro clutches, and here is the gear changing mechanism. And now let's just take a look at how this thing works. First gear, second gear, third gear, fourth gear. There. Of course, this, since it's in neutral, it just spins because of some friction. And now reverse. There. The lever, like in a real gearbox, springs back into the center position. Here's a special throttle pedal that regulates the throttle linkages in the engine. It's basically just for show. Okay, and now let's take a look at how the internals of the gearbox and the clutch work. Okay, here we go. The gearbox is now away from the engine, and let's take a look at the clutch. Okay. Now the clutch is based on a rearward design. Basically, it's a Lego first. I haven't found a good clutch design on the internet, so I basically took examples from real life. There we go. This is the flywheel side. This is the friction plate, and this is the clutch cage with the springs. So the springs are those 3 pegs, which mimic basically the pressure plate on the back of the friction plate. But of course, because this is Lego and I cannot source a part that would fit the friction plate, the springs act directly on the pressure plate, on the friction plate. The friction plate slides on these. In reality, the axle going to the gearbox is splined, but I can. The axles are basically splines, but I cannot make make the axle hole on the wheel slide on the axles. So I bored out the center so that it can slide on those three. Why have I done this? Because when you put this back together, you will see that the wheel has to have a bored out center. Otherwise, it will just get stuck. Okay, so those, as you can see, those spin independently, and the wheel acts like a friction plate. What happens here? The bearing, the pressure bearing, presses down on the springs. They release pressure, and the tire separates from the flywheel. And those springs also create pressure that doesn't allow the tire to spin freely. There. If I try to spin it, I can't. But if I press the bearing, the wheel spins without problem. Release it, no way. So this clutch would suit, if it wasn't as big as it is, it would also be perfect for the LPEpower Mustang, but unfortunately it's a tiny bit too big. Okay, now the gearbox. As you can see here, this is the input shaft of the gearbox. This is the mechanism that presses on the pressure bearing to release the clutch. And like in a real gearbox, here we have a continuous shaft with the gears that is directly connected to the input shaft that comes from the engine. Unlike in Lego gearboxes, where the gears are a mess, I never understood how the Lego gearboxes work. But this is the way it works in a real gearbox, where the gears are arranged in sequence with only two shafts. The main shaft, where all the gears are fixed on the shaft, and the secondary shaft, where all the gears spin freely on the shaft. For this I had to modify a few gears. For example, this here is a 20-tooth gear that has the center bored out and the clutch mechanism installed. This is a 24-tooth gear from Lego differential, which was basically cut off. This is a combination of the clutch mechanism and the 12-tooth gear, glued together, of course. This is the standard 16-tooth clutch gear, and another one for the reverse. And that's how it is. Here you have the forks that are actuated by those. And let's take a look at the shifting mechanism. Here we go. Here is the mechanism for third and fourth. This is the mechanism for first and second. And here you have the safety with the spring for the reverse. So with the gear lever, you have to press on this lever. Then you can engage reverse. It's also spring loaded, so it snaps back, and you can't accidentally engage the reverse and one of those forward gears, because this in the real world this would be pretty bad. And that's basically it. It's a relatively simple gearbox, but it required quite a bit of development because there was no precedence, no gearbox that I could draw from. Here you can see those springs. The springs are basically to secure the gears in the center position, so they don't slide around. You can find similar things in real gearboxes. It also helps the feel on the gear lever, so you know that you shifted gear. Tactile feedback is always good. Yeah, that's it. Next time we will take a look at we will have a series of suspension setups where I will show you how to modify the standard Lego double wishbone suspension to achieve some real-life geometry. And if you have any questions regarding the gearbox, please ask them in the comments down below. I will also post pictures of the gearbox and the clutch on LPEpower, also links down below. And that's it. Please like the video and see you next time.